And as I talk, you can type into the chat bar. It would be great if you would let me know if you can hear me. I think the sound's set up right now, but just to let me know if you can hear me. By typing a response into the chat bar. Okay, your questions will go there too, and then there is a little bit of a delay between when I talk and when you hear me, so just give me a minute and I will get to your question. But for right now, we're going to start by looking at a few basic questions about logarithmic functions. Oh, you haven't heard anything since? That's not good. Okay, so apparently there's a problem with the sound, so I'm working on that. But, oh, okay, good. You can hear me now? Perfect. All right, so let's go ahead and talk about the basic idea that's so important to understand, so important for you to be successful on the test on logarithms, is how to go back and forth between exponential and logarithmic form. Because remember, the logarithms are really just a way of looking for a missing exponent, so there's a direct correlation between the two. So here's an example of a question that you could be asked. I'm sure you're going to have something similar to it on your test. And that is, if we have the exponential expression 2 to the negative fourth equals 1/16, which logarithmic form would that correspond to? So the way that I always approach this problem is I remember that, for example, if we had the expression log base b of n equals m, for example, then we read this aloud by saying log base b of n equals m, and I know that logs are always looking for the missing exponent. So the way we read it, because it says base b, reminds me that this little subscript down here under down to the right and low below the g, that's the base of the log and the base of the exponential expression. And then the number after the equal sign is the missing exponential expression. So that reminds me that if I want to write this in exponential form, I always start with the base of the exponential expression and the exponent, so b to the m, and then that third number has to be what it's equal to, so b to the m equals n. That's how I think through it. We're going backwards, of course, this time, so we're starting with the exponential expression that has a base b, and the exponent is m. That's what the log will be equal to. And so this must be the argument of the log. It's the last thing left over. So I would say, okay, I'm going to write my log with a base of b. I'm going to take log base b of n and get the exponent m. All right, so we need to be able to go between exponential and logarithmic forms. Here we're given an exponential form. And I just want to erase that. Okay, so here we're given an exponential form and we're asked to find the logarithmic form. So let's identify the parts. So the base is 2 in this case. The exponent is -4, so this must be the argument of the log here. So that would mean that we're going to have log base 2 of 1/16 equals -4. Or another way of saying that is the power you raise 2 to get 1/16 is -4. That's what we had here, right? So that would be item number D. Log base 2 of 1/16 is -4. And by the way, there are two of these potential answers that you can throw out right away. We never have a negative in the argument of a log, that's undefined, and we never use a negative base. So the only two possibilities are C and D, really. Okay. All right, so that would be the logarithmic form. And get another log-related topic. Before we get into solving exponential equations, I want to make is the change of base formula. See, on your calculator, the only logarithmic bases that you have are base E and base 10. And so this one is base 5, and it's asking you to use a calculator to approximate it. So we have to know how we could possibly do that, and the way that we do it is we convert it to one base E, or the natural log. B of n is equal to the natural log of n over the natural log of b. So the natural log of the argument over the natural log of the base. Remember, natural log means log base E. This is an we could, in this case, then log base 5 of 6 would be the natural log of 6 over the natural log of 5. The natural log of the argument, that's a 6, not a b, over the natural log of the base. All right, then you would get out your calculator and you would say natural log, you'd use the natural log function of 6, you might have to close some parentheses that it puts in automatically, divided by the natural log of 5. So let's go ahead and do that. All right, so we want, and this most of your scientific calculators works. See here, where's my base E? There we go. So we have the natural log of 6. I have to hit 6 in the natural log. You probably are going to type natural log parentheses 6 close parenthesis, but mine works a little differently. And then we're going to divide by the natural log of 5 and hit equals. So we get 1.11328. So that's rounded to 4 decimal places. That's going to be C. Now the interesting thing is that you can actually use this rule to convert to any base that you want. For example, take log base 5 of 6 and instead say, well, that's going to be the log of 6 over the log of 5. Log is base 10, right? We don't write it, but it's base 10 unless another base is indicated. 6 divided by log of 5 should turn out to be the same thing. So let's try that. So we're going to go 6. I hope you're trying this on your calculator at home so you can make sure you know how to get the do this operation on your calculator. And see, we get the same thing there. Technically, we could have changed it to any base. I could have said log base 5 of 6 equals log base 7 of 6 over log base 7 of 5, for example. Not very often when we do that because our calculator only has logs, the common logs and the natural logs. Okay, so that's how when you're asked to get an approximation. So the exact value of log base 5 of 6, that's log base 5 of 6. There's not a better way to write that. But if you want an approximation for some reason, that's how you would get it on your calculator. Use the change of base formula. So this guy here is called the change of base formula. Okay, so that's a formula you'll need on your test 4 and your final. All right, another dated question that we haven't really gotten around to is writing the domain of a logarithm. So remember how I said that you'll never have a negative number in the argument of a logarithm? You'll never have a 0 either. In fact, if you recall, we did graph y equals log of x, and in general, regardless of what the base is, this is going to have a vertical asymptote at x equals 0. It's going to go through the point 1, 0, and it's going to look like this. Notice that the domain of this function is everything past 0 to the right. So 0 to infinity, not including 0, which is why I have parentheses here. Okay, so that would be the domain of your standard log. In fact, any base b, it doesn't have to be base 10 or e, any base. All right, so now in general though, what that means is we want our argument, in this case the argument was just an x, to be greater than 0. So if we change the argument, make a transformation to it, then that needs to be greater than 0. So if you want to find the domain of this variation on the log function, you're going to set 7 minus x greater than 0 and solve that inequality. So let's see if we can do that. We're going to subtract 7 from both sides. We have negative x is greater than negative 7. We're going to divide both sides by negative 1 or multiply by negative 1, however you want to think of it. But remember, when you do that, you have to flip the inequality symbol. So negative x divided by negative 1, but I have flipped the inequality symbol. So that means that x has to be less than 7. And we would like to see that in interval notation. Remember, x less than 7 means everything to the left of 7. So that would be everything from negative infinity up to, but not including 7. So that would be the interval negative infinity to, oops, that's supposed to be a positive, to positive 7. So that would be A. Okay, so those are some things that are going to come up in your homework. I just wanted to make sure you had seen them. But the focus of today is going to be on solving exponential and logarithmic equations. So